Turn coordinator. We have them. We love them. I got a great relationship with this thing right here. And it's kind of a love-hate relationship. Okay? We do not need any part of that instrument for VFR flight. Which means for you guys in this program, you don't need to know not one thing about it. Nothing. All I have to do is teach you about some gyroscopic instruments, which we're going to talk gyroscopic instruments, but you don't need any of them. It's not required for you to fly VFR. Boy, sometimes, and I don't know, it's what I would consider novice instructors, which is a lot of them, and probably by the time they get pretty good at instructing, they start flying something bigger. So a lot of instructors are going to tell their pilots, hey, you're not flying coordinated. Look at the ball. Terrible. Terrible. Can you look outside? Right? If you can look outside, you can tell if you're coordinated. Trust me, you can. Okay? You really, really can. Who's heard step on the ball? I heard step on the ball. Step on the ball. Step on the ball. I don't even know if that ball is calibrated properly. You do know that there are screws that attach this thing to the panel, right? And those screws sometimes, if I take them off, that'll allow me to adjust this thing. And sometimes maintenance puts these things in here, and they're not put in exactly straight because maintenance just put it in, turned it on, and away it goes. They don't need it. They're flying visual, right? So if you're sitting on the ground and that ball is halfway across here, now you're flying, you're trying to keep the ball centered, it's not straight. You're not straight at all. You got to fly the airplane straight. So, you know, my little tidbit on these things, a lot of times they're not calibrated properly. Don't put a whole lot of weight into this. The only time I need to look at this thing is when I can't see outside. If I'm flying inside a cloud. You guys right now should not be flying in clouds. You're not allowed to, so don't do it. Continue to look outside, keep your airplane straight. As far as the turn coordinator is concerned, this thing will show movement around the yaw and roll axis. So if I'm turning, bank the airplane, and I cause the airplane to change direction, that will indicate a left turn or a right turn. Okay? This will give me a standard rate turn. It'll show me a full turn at standard rate in 2 minutes. None of the stuff I need to know. Not until instruments. We learn all this in the instruments. But it will also show me a change in direction if I just turn the airplane without banking. I.e., if I'm on the ground and I'm taxiing. I'm not banking the airplane at all. I'm just taxiing, but I'm changing my direction so it will show me a turn left or right. Gives me absolutely no pitch information. This instrument also gives you zero information about bank. It only shows you the turn, okay? It doesn't have anything to do with bank other than you're either turning left or turning right, and I don't know if that's a combination of me banking one way and having an uncoordinated turn or not. So interesting little device there, but we don't need to know about it. We don't need to know much about it. Something else that's interesting that is always available to me outside the windows. This is your artificial horizon or your attitude indicator. Or if I had this together with Flight Director, maybe an ADI. Okay? So this will give me information based on my airplane's relative position or attitude position to the natural horizon, pitch and bank. And I can measure that in degrees. And I can adjust the miniature airplane while I'm in level flight. Okay? This works off of a gyro. Who knows what a gyro is? Anybody not know what a gyro is? All right. Think about something that moves very fast, but is very rigid. So if we had a top, you know what a top is? Yeah. It's kind of cone-shaped, and it's got a handle on. So I can turn that, and it spins just on the very, very point, and it stays erect. By spinning this thing, I've done exactly what it turns and stays rigid in space. Well, this thing turns 20,000, 30,000 RPM, whatever it is. It's a little brass gyro, and it turns very, very fast. No matter which way I change my flight attitude, that gyro will not move. It stays exactly where it is. So when I bank my airplane left or right, and when I pitch my airplane up or down, I'll get an indication here of what my airplane is doing with relationship to the natural horizon. Are you guys going to use this thing? No. Why not? Why would you not use this?
In clouds.
Well, you're not going to be in a cloud, right? Why else wouldn't you use it?
IFR.
Well, you're not going to go IFR either. Why would you guys not use this thing?
In steep turns.
Not even then. You can look outside and tell when you're 45 degrees. Do that pretty good.
Because it's, this gauge is not required for VFR, and actually we use horizon, natural horizon.
Because you're using the natural horizon, that's why. Okay? What is this called? What is this instrument called?
Attitude indicator.
Attitude indicator. Okay, anyone ever heard this called an artificial horizon? Maybe we've heard that. Artificial horizon. A fake horizon. Yeah. Artificial horizon. Yeah. Artificial, like, you ever seen plastic fruit before?
Plastic
Fruit.
Artificial.
Like like somebody has a bowl and it has plastic grapes and plastic orange and plastic banana. That's decoration. You're never going to eat it, but it's there as decoration. You never have to replace it, right? It'll stay like that forever. Well, that's artificial fruit. It's fake. This is an artificial horizon. It's fake. It's not a real horizon. It's a replication of a horizon, just like the plastic piece of fruit is a replication of fruit, but you're not going to pick it up and eat it. I can't look at this and consider that a real horizon because it's not. But instead, what do I have outside all the way around my airplane? The real horizon, the natural horizon. So I encourage you to make your flight references to the natural horizon. That's a very, very, very important step in being successful in flying airplanes. Problem is, what do instructors do? Instructors do this exactly, and watch. Private, instrument, commercial, instructor. So what are they teaching you guys? Right, one of the last things they learned. They're pretty good at instruments, and they're going to start teaching you, hey, look at this thing here, and you got 30-degree bank there, and 45, and steep turns, you can pitch this up. It's just natural for them to do that because they recently got done using their instruments a lot, okay? But I encourage all of them, and I encourage you guys, just take a step back. Go back to that airplane flying handbook. Get out of the instrument flying handbook because you're not there yet. Go back to the airplane flying handbook, which says use your natural horizon. That is the best way of obtaining direct information on your relationship to the horizon. Attitude, pitch attitude, and bank attitude. Now, 45 degrees for a steep turn, great. Anybody in the world has seen, I don't think we have a picture frame in here. Yeah, okay, we got something here. Look. Anybody in the world could see this angle right here. What angle is that?
45.
Okay, thank you. You didn't need a compass. You didn't need a ruler. You didn't need a stethoscope. You know it's 45 degrees.
Yeah.
Put that angle on your glare shield and fly the airplane, right? It's not too hard. Anyways, let me get off into any kind of craziness.
Yeah, for glass. Again, you use glass. Glass and water.
Glass.
Glass
The
and
water,
water.
the water level in glass, he means.
Yeah.
That was some of the very first instrument flying that was ever done. Did you know that? But it wasn't, well, compass, sure, but it wasn't glass in water. It was a glass of whiskey.
Aha!
So true story. We start this thing where we're flying airplanes. Okay, the Wright brothers are flying airplanes, and somebody over in Europe decides they want to make airplanes. The next thing you know, who can fly faster, higher, everything in the world. Okay, great. What do you guys know about American history? And I'm asking a question and we'll figure this out. It's really, really easy American history, but easy for me because I grew up here. How did our mail go from city to city? In other words, if someone in New York City wanted to send mail to someone in El Paso, Texas, how would it get there? Any ideas?
When?
Before the airplane.
Oh, before the airplane. By horse.
Pony Express. That's right. Eventually we started getting trains and who knows what. They would get the long haul movement, maybe hub to hub, would go from New York to, let's say, maybe St. Louis, Missouri. I don't know where even our railroad system goes because I just don't know. But a long part of that trip would be on a railhead, and then Pony Express would take it across. So if I was in New York and I wanted to tell someone something very, very quickly, or maybe get someone to sign a piece of paper, which I couldn't send over a telegraph, because I wanted to tell them maybe I could telegraph. If I wanted to send something to them and have them sign it or read it in their hands, it would take a long time to get there. Okay? Well, as soon as airplanes started as soon as we started enjoying airplanes, one of the very first jobs was airmail. Now, do you know how to identify? Do you know from years back how people on the ground could identify a mail plane? They could identify a mail plane by looking at the testicles. Mail plane, mail plane, male, female. I'm only kidding, that was a joke. You guys are a hard group. Okay, so no, not a mail plane, okay, but U.S. mail, we had mail planes, okay?
Okay, I get it.
By balls.
Okay, so mail planes were a real thing, like U.S. mail. And that job paid a lot. That job paid like $30 a month in times when $30 a month could buy you a new house each month. These guys were really getting paid a lot of money, okay? But the life expectancy was almost nothing. The life expectancy was, they were not, you might make, a couple weeks, couple months, and then, oh, there goes Sam. Couple of things here. Why was it so dangerous for them? Well, number one, getting through the cloud, right, because they would have to go above the cloud, was dangerous. And once they got in it, they didn't know what in the world was in there. Thunderstorm, ice, they had no idea what to do with this thing. So they might die just from natural consequences of being exposed to this stuff. The other thing was just keeping control of the airplane. And that's where they had a glass with whiskey. And they would set that bottle of whiskey up there and keep the airplane level. It's a true story. Plus, if you got a little freaked out and the whiskey started going all over the place, hey, you had whiskey. Right? That's a true story. It's a true story.
Also, aviation investigation story by canal.
Discovery Channel.
Yeah.
Yes. And true story about civil aviation.
That's true, yeah. These are real facts. Plus, not only that, so does everybody know what I mean when I say water tower? If I say water tower, are you guys okay with me saying water tower? There's a big giant ball full of water that provides water pressure to everybody here in the county or wherever we're close. That municipality, okay? Do you guys know why the name of the city is on all of these water towers? Mm-hmm. Have you seen that? Like you go by Hollywood, for instance. Yeah, you're on 95, you can see Hollywood. The big blue, and it says Hollywood. They spent more money than some of the police salary. They didn't increase police salaries that year. Hollywood police got paid the same 2 years in a row. Oh, boo-hoo, whatever, I know, police. But they painted that thing instead of giving their policemen raises. I don't know why, whatever. But yeah, they got the name of the cities on all these water towers, right? Do you guys know why we do that in the U.S.?
For navigation of airplanes.
Once the airmail pilot right? Once the male plane, you missed my joke, they missed my joke too. All I could hear was the whoosh. You know what that sound was? My joke going over everyone's head. Whoosh. So, but the airmail, right? When the airmail pilot came down below the cloud, they would find a water tower and they know where they are. And that was the first time in the last 3 hours they knew where they were. Yeah.
Yeah.
Right.
It was something like a beacon.
Well,
Like a nature beacon, nav 8. Yeah, like a nav 8.
yep, that's right. And before that was all dead reckoning. And none of them knew anything. And they probably already drank the whiskey. Anyhow. All right, let's take a look at a couple of things here. So, real quick, we got to discuss magnetic compass. A magnetic compass, you do need. But magnetic compasses are interesting because they have a little bit of some errors, a couple of errors. One of them in particular that we're going to discuss, and is dip errors. And they also align themselves with magnetic north, okay, which is just a magnetic field that surrounds the Earth, and that's constantly changing. True north is how we, as, I don't know, I guess the modern era, and the modern era lasts several hundred years, we navigate ourselves around these territories and these lands, okay? It's because they've divided everything into a latitude and a longitude. And with everything divided into latitude and longitude, all of these longitude lines, they intersect at 2 points, at true North Pole and true South Pole, okay? The magnetic north and the true north do not coincide. In other words, those two things are not the same points on Earth. So while I'm navigating, I need to think about my flight plan, which is on a piece of paper, which references latitude, longitude, and how I'm going to fly that airplane using what I have on board. Nothing on board my airplane will show me true north. Nothing on there will point to true north. But the magnetic compass will point to magnetic north. Okay? Couple of interesting things here. One thing is, and I'm not sure why, honestly, I need to get some trivia on this. I'm not sure why that's called a lubber line. Oh, wait, that's what it's called. It's called the lubber line. And you'll see a couple of these in different instruments too. All right, what does the inside of this thing look like? Ta-da, you're welcome. Not important that you know much of this. There is fluid inside there. Does anybody know what that fluid is? No surprise, it's a... Whoa, kerosene! Yeah. I've only come across it... Well, you're an avionics guy, of course. Of course you'd know. I've only come across a few people ever that have known that. That's exactly right. It's in kerosene. Okay? So I'm going to check to see that the magnetic compass is full of fluid, no cracks, no bubbles, no leaks, right? And moving freely in known directions. All right, that's great. Other than that, the expansion unit, I don't need to know that. Compensating magnet, this is just how they could make adjustments to it, right? In order to make adjustments to a compass that doesn't operate or function properly. Sensing magnet, this is what aligns to the magnetic poles. You have a lens, a card that we read our direction off of. The lubber line, again, not sure why it's called that, but it is. And the only part of this entire device or this entire instrument that requires electricity is the lamp. And that's also the only part that usually doesn't work. Okay? So take a headlight with you. If you're going to fly at night, red filtered lens, take a headlight with you. Okay. Here is a magnetic field of sorts. Now, I've asked pilots from all sorts of different backgrounds and nations and languages and everything else if they're familiar with something that we used to have to do in elementary school. And I can tell you that I usually have not been successful. Most people don't know what I'm talking about. I'll give this a try. Has anyone here ever in class, college, experiment, seen on TV, elementary school, whatever, seen or observed a small container of metal shavings, right? Very small metal shavings with a magnet dropped inside it? Anybody seen that? You have? Wow, right. Have you?
Yeah.
Well, you have? Have you?
Of course.
Yeah?
Yeah, sure.
You get? This is great. This is going to work out great. They don't teach that in Latin America. From Texas down, nobody knows. Believe me when I tell you that. Okay, so those metal shavings are actually following, and in our case, making this magnetic field visible to us. It looks exactly like this. It looks exactly like that. But when I tell people, they're like, I've never seen this before, and you're like, I don't know what in the world you're talking about. Okay, so what does that mean? That means that if I go back to this sensing magnet, which is here, okay, keep in mind that's the magnetic compass, that sensing magnet will always align itself with this magnetic field. That's how we get the indications of magnetic north, right? So my direction relative magnetic north, because that sensing magnet is aligned with this magnetic field. Great. If I take a look at it like this here in a two-dimensional plane, that's fantastic. Where it gets a little bit interesting to us as pilots is when we're flying anywhere other than directly the middle of this. Because do you guys see how these magnetic fields here are parallel to this magnet? And here, they are not parallel to the magnet. In fact, they dip at an angle. Everybody okay when I say that dips? Mm-hmm. So if I look at this line, this magnetic field, it's parallel here. But as I come here, there's an angle between the two. That's called a magnetic dip. Okay? And that dip will make the magnetic compass indicate some bad information. It'll show me information that is not true. Which is unfortunate because that is one instrument that I have to have in every airplane. You guys ever been in an airplane that didn't have a magnetic compass?
Yeah,
You have?
I have.
Where?
So here is on the glare shop, above the glare shop.
No, have you ever been in an airplane that did not have one?
Did not have. I don't remember.
I've never been in an airplane that did not have one. And I've looked, I don't know if we have, do you got the A320 up there? The other part? Yeah, it has one, right?
Yes.
Yeah, everything is there. Now, do we ever look at it? Probably not. You're never going to look at the thing. But it's required. So what I'm telling you is that each airplane that you fly will have one of these things in it. It just has to. And when that sensing magnet aligns with this, it gives me an indication of which way I'm going, unless my airplane is accelerating. And you can accelerate two different ways. You can accelerate velocity-wise with a change in your speed, or you can accelerate with a change in your angle, or change in direction, in other words. So any of these acceleration errors are witnessed by us as pilots. So I can see here, this takes that magnetic pole and it puts it right over the Earth, and then I get a north magnetic pole, I get a geographic north pole, who cares about that? But these are the errors, the dip errors, that are experienced by us as pilots while we're trying to use the magnetic compass. And these are all of the different ways that you could express that. So, if we look at it, we got unos, nos, and ands. A couple of real quick acronyms, right? Most instructors, and like I say, when I talk novice instructors, I'm usually broad brush talking about that pilot that's going to instruct for a year and go to the airlines. Most of them will know and will teach unos and ands. So as a result of that, most pilots in our community will understand unos and ands. Okay? This one is commonly the one that examiners or written tests will ask questions for you to answer. Okay? Now follow along with me for a moment. This is a new building, so I don't know quite which way I'm facing. I think that way is west. Right? I think so. We came in that door. Yeah, there's west. Yep. All right. So let's say, for instance, I'm flying my airplane and we're flying west. Okay? Or I'm flying east, which is this way. either one of these two directions are going to give me errors with regards to accelerating my speed. Right here, easterly or westerly. Now, quick story, once, and I've been teaching this class or a class similar to this since I think since 2003. Okay, so it's been a while. One person asked me after I finished the whole lesson, the whole, 5 minutes, whatever I'm talking about this thing, one person raised her hand and said, "Why does that have anything to do with Easter?" Nothing to do with Easter. She was on holidays. The whole time I was talking, she thought I was talking about holidays, Easter. I was like, I didn't even know what to do with myself. Anyway, so easterly or westerly. If I accelerate the airplane and I don't turn, so in other words, let's say I got just a rocket booster worth of power here, and I accelerate that airplane, it's going to cause the magnetic compass to indicate a turn towards the north. I didn't turn, but the compass will move north. Okay? Remember, this is in the northern hemisphere. Only northern hemisphere. Okay? That's the scope of this course. If I decelerate, put on the speed brakes, the compass will move towards the south. I didn't turn. Just the compass shows me a change to the south. Same thing if I'm westerly. Has nothing to do with Easter. But if I accelerate, goes north, decelerate south, you got ands. Okay? Everybody can remember that. It's easy. We have 160 horsepower in these Cessnas. You're not going to accelerate that much using 160 horsepower. But what you will do is you'll accelerate and decelerate using your pitch angle. You can slow the airplane and speed the airplane up a whole lot with the assistance of gravity. Okay? So you will, that's the other question I get usually is, hey man, we got a Cessna. You're not going to accelerate that much. Hardy, har. Okay, you ever pitch? You can accelerate and decelerate that airplane quite a bit. Okay, let's go to Unos. All right? Now, I'm turning towards south or north. So right now I'm facing west. All right? I think logically that means this way is south and that way is north. I'd always check myself. If I'm turning towards the north or south, okay, I have to undershoot. Looking at that compass, I have to undershoot a north heading by about 30 degrees. So before I get to north, I'm going to be, maybe 330. I start rolling out. The airplane has stopped turning, and then the magnetic compass will line up with north, okay, because of dip errors. If I'm turning towards the south, I have to let the magnetic compass go past south. Just go all the way beyond south by about 20 degrees, where we are in latitude here in Florida. Go about 20 degrees south and straighten the airplane. It will come back and show south. Dip errors. All right? That's how this stuff works. Now, the one in the middle is the one I tell you that this is where the conversation happens. Okay? Because that's usually the one. Honestly, there's a couple of things I pulled out of different books and different slideshows on this. I put this Excel sheet together myself. Can you believe that? This is my own work. And she asked me about Easter. All right, so north. Let's say we're flying north. I'm flying north and I turn. It doesn't matter if I turn left or if I turn right. Does not matter. If I turn, the magnetic compass will show a turn in the opposite direction. So if I were watching this magnetic compass and I turned one direction, now this way I'm turning west, initially it's going to show a turn to the east. If I don't understand that that should happen, it will confuse me. It would be very, very confusing. But that's why we study these things. Okay? Not many pilots work off the magnetic compass anyways, but we need to have a little bit of understanding for it. Now, if I'm turning away from south, and I'm flying south, okay, and I turn away from south, it will turn in an exaggerated motion. When I do these demonstrations on the flights, I turn the I'm flying south, and I turn the airplane in a medium bank turn. A medium bank turn towards one direction or another. It will almost instantly show west or east. And then I'll straighten up and it will continue showing east or west, whichever way I was going. So it gets there very quickly. That's the nose, the north, opposite, south, exaggerated. Okay. And you guys are all welcome. Here we go. This explains exactly the same thing. This one comes out of the Pilot Handbook of Aeronautical Knowledge. Like I said, I chopped some of this stuff out of materials. All right. It's showing northerly turning area, or northerly turning error. Flying north, the airplane turns to the right. What would I expect? Well, I'd expect if I was flying north and I turn to the right, this gives me an east indication. Instead, you can see how the magnetic compass turns because of the dip errors and shows west. The same thing if I'm flying magnetic south. I'm flying south, life is good. I make a left turn, so south, I make a left turn, I'd expect west. It does show me a turn towards the west. However, it gets there very, very quickly. Okay? So that's me flying in your northerly turning errors. All right. Acceleration errors. Acceleration, deceleration. The airplane's flying east or west, and some combination of that. If we accelerate, the airplane turns towards the north. You decelerate, the airplane turns towards the south. The final thing that we need to discuss for magnetic compasses, the compass card. I encourage you to, whatever favorite flavor of Cessna that you have out there, just take a picture of the compass card. On the compass, there's a little card below it that'll show you exactly like this, for whatever heading you want, you have to steer this on the magnetic compass. It's usually not much, 2 degrees, 4 degrees, right? 5 degrees. Whatever the case, usually not much. And this is an exaggerated model. Take a photo of that because you'll need it to do your flight plan properly. Because part of that is your magnetic deviation. This is your deviation card. You'll also need it because if you get in an airplane and it doesn't have it, the pilot before you took it out, or after years and years and years of it being there, it's sun faded and we can't read it. Well, this is required. Remember, we go back to those placards and everything that we're supposed to have? You're supposed to have one of these things in the airplane. So if you don't have one in the airplane, you got a picture of it on your phone or a picture of it out of the maintenance book, this will still work. Technically, if wherever you are, get a maintenance ramp check, you can print that out inside the FBO on their terminal computer and then put it in the airplane, you're good. Okay? All right, so one of the things that's not commonly used, but it exists and we have to comply with the regulation. All righty. You guys want to muscle into chapter 3? This is the last chapter, and this way, I promise chapter 3 is